Hi guys, welcome back to my channel. So in this video I'll show you guys how to perform the multiplication into binary. Okay, so the multiplication in binary is same like we perform the multiplication into elementary school. So remember, if you had like something 72 times 13 and you were in elementary school and you had to perform this, so you would do like 3 times 2, that's a 6, and 3 times 7, that's a 21. So you put 1 over here and 2 at the top. Okay, and then you bring the 2 here, and then next, before going to the next one, you put an x over here, and then you put like 1 times 2, that's a 2, and then 1 times 7, that's a 7, and then you would go ahead and add these up, right? 6, 3, 9, right? So this is how you would do it elementary school, right? But so you're basically following the same procedure. Okay, so let's go ahead and remove this thing. Okay, so we have this number over here, which is 3 bits, and this is the 3 bits. Okay, so before you go ahead and do the multiplication, you have to figure out how many bits it's gonna be your final answer. Okay, so since you have 3 bits here and 3 bits here, so you're simply going to add these up. So your final answer will be 6 bits. Okay, and since our final answer is going to be 6 bits, we need to sign extend this to 6 bits. Okay, so we have our first number, but it's in 3 bits. We need to sign extend it to 6 bits, so we can add zeros over here to make it 6. Okay, now again the second number, and we're gonna go ahead and sign extend it to 6 bits. Okay, so now once we have these sign extended, we can go ahead and multiply them, right? Just like usual. Okay, and like when you had numbers, right, so you were multiplying, right? Here you're not multiplying, you're actually ANDing them. Okay, you remember the AND truth table, like when you have A, B, and F. So here you have the AND truth table, so every time you have both of them equal to 1, so then it's a 1, right? Otherwise it's all zeros. So you're basically doing the same thing over here. So you have 0 and with 1, that's a 0, right? 0 and with 1, that's a 0. Unless you have both of them equals to 1, then it's 1, otherwise it's all zeros, right? So this is 0, this is 0, this is 0, 0, 0, 0. And then before you go ahead to the next one, what do? You put an x over here, right? And then you go ahead and multiply these, right? So 1 and with 1, that's a 1. 1 and with 1, that's a 1. And the rest of them, you have 4 zeros, right? So, and then before you go ahead and move to the next one, put 2 x's. But you see the rest are all zeros, so you will eventually end up having zeros, right, all the way. And then you will do the same thing. So you can go ahead and continue this like 1, 2, 3, 4, 4 times, but it won't change anything. So if you want, you can go ahead, but it's useless. So now you can add these up. So here we get a 0, here we get a 1, here we get a 1. Okay, we are adding in binary. So for example, if you have something like 2 over here, so 2 is 1 0 in binary, right? So you're going to put like 0 over here and then 1 at the top, and then it's gonna be like how you perform the addition in binary, right? Okay, so here we have 0, and the rest is just 0, 0, 0, 0, zeros, and if you continue, you're gonna have like more zeros, right? But since our final answer, we know that it's gonna be 6 bits, so we're only going to take 6 bits. Okay, so 1, 2, 3, 4, 5, 6. So this is going to be our final answer, and the rest you just discard. Okay, let's go ahead and perform this operation. So here we have this, and we have this question, but it was with operands. Okay, I forgot to write the whole question. Okay, so we have this. Let's go ahead and solve this, and yeah, make sure to know like the multiplication with the 2's complement very well, because this was a midterm question as well. We were given a negative number and a positive number, and we had to multiply. But here it's the answer is going to be really long, but it wasn't really long in the exam. But so just make sure to know the idea. Okay, so now here we have a negative, so we need to perform 2's complement, right? So the number 9 in binary, if you convert that, so it should be 1001. Okay, only the magnitude, because for the 2's complement, remember, you're going to take the unsigned number. So that's why I took unsigned, like without the sign, only the magnitude. Okay, now we have the number in unsigned, but we need it into 5 bits long, right? So here we have 1, 2, 3, 4. We only have 4 bits, so we're gonna go ahead and add 0 here to make it 5 bits. Okay, now we have 5 bits. We're gonna go ahead and perform the 1's complement, and 1's complement is what? We're simply going to flip the bits, right? Just going to inverse it. So if it's 0, we put a 1. If it's 1, we put a 0. It's 1, we put it's 0, we put a 1. It's 0, we put a 1, and it's 1, we put a 0, right? Simply going to inverse it. Now for 2's complement, what do? We're simply going to add 1 to 1's complement. Adding 1, we have 1 over here, 1, 1, 1, 0, 1. Okay, so this is our answer in 5 bits for negative 9, right? So negative 9 in 2's complement. Why did we convert it to 2's complement? Because it was a negative number, and we need to convert it into 2's complement before multiplying. Okay, so we have this number in the 5 bits. Now we need 3 in 5 bits, and it's not a negative number, so we don't need to convert it into 2's complement. So 3, you already know, it's 1 1 in binary, right? So if it's 1 1, but you need in 5 bits, so what you're going to do, sign extend it to 5 bits. So adding 3 more zeros, this is 3. Okay, now you have both numbers, 3 and 9, so we just have to multiply them, right? But again, remember, you cannot simply multiply them. What we did in the previous question, let me recall. So here we had 3 bits, so we add these, and the answer was 6 bits, right? So again, we have 5 and 5, so that means your answer is going to be 10 bits long, and it's gonna be a really long multiplication, right? So now go ahead and perform this, but let me show you how it's gonna look like. Okay, so you have something like this. Okay, so you have the first number as this one, right? You have 1 1 1 0 1, and since it's a 2's complement, and in a 2's complement, how do you sign extend? You have to sign extend it to 10 bits. So to sign extend in 2's complement, when you have a 1 over here, you put 1's, okay, to sign extend it. You do not put zeros, okay? This is very important. So that's why they sign extend it to 10 bits, this number, by adding 1 1 1's, okay, here, and then they sign extend this number here. This was a positive number, so simply adding 0 0 0 0 over here, okay, and then they multiplied, okay. So they did this thing, they they and them, so 1 times 1, that's a 1, the 1 times 1 and with 1, 1 and with 1's, okay. So you add these up, and then the final answer that you get, you only choose the 10 bits, okay. See, 1 2 3 4 5 6 7 8 9 10, so only there are 10 bits is gonna be the answer, the rest you'll discard. So that's it. Hope you find this video helpful, and thanks for watching. Bye.